So the next presentation is going to be over engineering your home with digital twins. So for this presentation, we have John Remy, who's joining with us today. He's the CTO of Theodo, and he's also an AWS community builder focusing on serverless. Without taking much time, let's invite John Remy on stage.
Great. Wow. Hello, everyone. So my talk is about over-engineering your home with digital twins. So the catch is we applied it to your home, but really, most likely, you're not going to use this at home, but probably in your work somewhere in a factory or on some construction site, for example. So the agenda of this presentation, quick introduction about myself, quick introduction of what a digital twin is, a presentation of AWS IoT TwinMaker, and how you actually would build a digital twins of a door at home, and finally, suggested next steps. So I'm Jean-Rémy, you can call me JR. I sort of rebranded when I moved to the US 5 years ago. I'm French. I live in New York, where I'm the CTO of the US branch of Theodo. We're a dev shop of about 700 people across Paris, London, and New York. And in the US, we do a lot of work with the fashion industry, connecting design and manufacturing systems together. We do a lot of serverless work, hence my serverless sucks, and, and the fact that I'm a community builder on the serverless track. And one funny thing about me, or I don't know if it's funny, but I'm really interested in languages. Not that I speak that many languages, but I like to observe how languages are similar or sometimes different. So for example, what sound does a dog make? A dog says woof woof, but in French actually a dog says waf waf. But really, they say the same thing, but it's funny how different languages give the same sound a different sound. Same thing with a cow. An English-speaking cow will say moo, but a French-speaking cow will say moo, which I think is more elegant, but it's up to you. Now I have a trick question for you. What sound does a door make? Well, ideally, a door makes no sound. If it does, it's a squeak in English, but we don't have a French word for it. Maybe what that tells you is that we know when to lubricate our doors in France. So what if you could measure data about a door, say how many angular degrees your door opens over its lifetime, gather this data, send that data onto a computer or into the cloud, on computers in the cloud, process that data, maybe visualize it on charts or on a real-time 3D representation of that door, and then use business logic or AI to tell you, hey, it's about time to lubricate those hinges so that your door doesn't start squeaking. So that's what a digital twin is, a pretty useless one. So in other words, a digital twin is a physical system that is connected to a digital representation of that system in the digital world, and that helps you drive better outcomes, business outcomes or family outcomes, like when I'm going to sneak into my baby's room, I'm not going to wake him up with a squeaky door, and that makes the family happier. So if we take a step back and we apply that to a business context, what you need to build a digital twin is a physical system, like a factory. You need a bunch of sensors. They can be temperature sensors, distance sensors, noise sensors, video sensors, also known as cameras. And you collect all that data. So they can be video streams or simple time series of data points like temperature, etc. Collect that data, send it somewhere safe. So some people collect that data on site in their factory or send it to the cloud or a mix of both. For example, if you have multiple factories, maybe you want to aggregate the data across all your factories across the country or across the globe, you need to store that data. You need to write business logic that's going to act depending on the data. Maybe you want to train an AI model on the data, and make it infer certain actions based on what's currently happening in your factory or in your bedroom. You probably want to represent that data as well, either with charts or with 2D or 3D representations. So there are many, many components to a digital twin. So it's a lot of work, and it's also a lot of work that no single person normally knows how to do. Enter AWS IoT Twin Maker. So IoT Twin Maker is a service provided by AWS to help you make digital twins. So for example, if you're a software engineer like me and you're not a very talented 3D designer, maybe you need help setting up a 3D representation of your data. I know how to send data in the cloud. I don't know so well how to represent that on a 3D model. So IoT Twin Maker makes that easy for me to create 3D representations that automatically react to and represent my real-time data. But Twin Maker is just one small part of the whole IoT suite of services provided by AWS. The idea here is that there are so many businesses around the world that already gather data. You may have factories that have sensors in place and that store some data on hard drives somewhere. You may have factories that don't measure anything and want to start implementing better analytics and predictive maintenance, for example. So every business is kind of at a different stage in their journey to creating a digital twin. So with that wide variety of services, the AWS IoT suite of services kind of meets you where you are in that journey, and you can pick up the tools that you will need. So I'm going to briefly present some of these services. So for example, Sitewise is a tool that easily helps you manage and collect and organize data that you're already gathering from different places. AWS IoT Greengrass is an open source solution that helps you, if you don't have any devices yet in your factory, you will use Greengrass to install an operating system that's already configured to gather data and send it to the cloud. So it kind of does the job for you of managing your fleet, setting up your fleet of devices. IoT Core is at the core of the IoT suite. It's like the main thing. It's the MQTT, so it's like the message bus that all IoT devices know how to talk to, sending messages. This door moved by a little bit, or someone pressed this button. So you will need IoT Core to send your messages and to have other services react to it. This Device Defender that helps you protect your devices. We all know that IoT devices are a prime target of hackers to create like large-scale attacks. So you want to protect them so that no one starts leveraging your devices for something you didn't intend to. So concretely, how do you make a digital twin of your doors at home? Suggested solution. First, you need to find a door in your home. I think we all have doors. Depending on your culture, maybe you don't lock that door, but you usually have a door. Then on that door, you can place a little Raspberry Pi Pico W in this case, so that has a wireless connectivity embedded into it, so you can just connect it to the Wi-Fi quite easily. You can solder into it a small motion sensor. Classic one is MPU 9250, which has a compass. So in this case, it has actually many sensors. It can like detect acceleration and other, acceleration against like on every axis, so linear, angular, but also what's really interesting in this case, it has a compass. So when your door moves, you can ask your compass every second in which position is my door. So from these positions, you can infer, okay, you've been turning your door 720 degrees in the past hour, for example. So once you've written the bit of code that gathers data every second from your door orientation, you send that into IoT Core. It's a typical time series data. So you're going to have many, many data points. So a very well-suited service to store that type of data is Amazon TimeStream, which gives you good optimizations for managing and querying time series data. And then you can send that data with TwinMaker extremely easily into a Grafana dashboard. And so TwinMaker gives you pre-configured Grafana dashboards that you can say, okay, please represent this data on this graph. My data is in this time stream table. And this is my 3D model, put it in there, and represent the angular position of this door on this 3D model. It's kind of easy ClickUps to configure it. And if you're not happy with that, because there are some limitations to the 3D representation part of things, you can also simply query your data with an API. So you could build a separate website that queries through API gateway the content on your time stream time series and connect that data with JavaScript into a 3D model, in this case with Three.js. You can use other solutions for that. So it's very, what I'm illustrating here is that all these services, all the services in the IoT suite of AWS are composable and have APIs, so you can really decide to use part of each service and use other services, custom solutions, or off-the-shelf solutions for the rest of your value chain. So once you've done this, where can you go? So you can train an AI model with, for example, SageMaker to predict with more accuracy. Okay, maybe depending on temperature, you can add more sensors. Maybe temperature will have an impact on how fast the grease in the hinges will wear out. So you can add more data inputs and train a model to give you better predictions of when to lubricate the hinges. You can also, I've not done that, but you can switch to one central Raspberry Pi that would connect with Bluetooth Low Energy to motion sensors on several doors in a room so that you have fewer Raspberry Pis in your home, which usually wives are happy with that type of business outcomes. And finally, you can, of course, hopefully, not of course, but hopefully you can get rid of your custom Three.js implementation when the 3D solution proposed inside TwinMaker will become more flexible, which right now it is not. And that's about it. So thank you very much for your time. I hope, yep, thank you. You can always find me. I'm going to be hanging out in this space. You can hit me up on X. I had a little Twitter logo, but it was replaced by an X logo, or by email. Happy to talk about these things. Thank you very much.